Alright, hello everyone, it's Mr. Kirsch. I'm going to go over our practice problems from today. Number 1 says find a particular solution with initial equation f of 1 is 9. Well, this is a differential equation. If I integrate it, the antiderivative is y is equal to x squared plus 3x plus c. And we can figure out the c because we can take this and plug in everywhere we're seeing x, we put a 1, and the output is 9, so we put a 9 there, solve for c, and now we can take this general equation and make it the specific equation because we've figured out what c is. Number 2, each of them say find the antiderivative. Well, step 1 is always to simplify it. I'm going to pull this constant out in front and make the square root 1/2. And I'm going to add 1 to this, and then I'm going to divide by divide by 3/2. However, dividing by 3/2 is the exact same as multiplying by 2/3. And it's easier just to multiply here. So we have 2/3, which is 4/9, and x to the 3/2. I went ahead and wrote x to the 3/2 like this. You could have left it like that up there. Don't forget to put a plus c on there because we don't know if there was a constant. Up here we were able to determine the constant. Here we don't have an initial condition, so we can't go any further. Again, let's rewrite this. Add 1, divide, -3, x to the -3. I put it back down in the denominator. Absolute value here, if you were to rewrite this, you would have 5x to the -1, and then you would add 1 and divide by 0, which cannot happen, so this process will not work. So you have to go back and remember from first semester that when we did the derivative of natural log, it was 1 over x. So you just have to memorize that one. This is a memorization problem here. And we do put absolute value. It restricts the domain. Just put those lines on it when you take the value there. C, since 2018, the average world temperature has been increasing at this given rate here. What was the net change from 2020 to 23? Well, that's it. The problem starts off with 2018. So this is year 0. This is year 1, year 2, year 3, year 4, year 5. So we're basically talking about year 2 to year 5. So there's 2 and 5. Integrate it, and then put this on your, after you find the integration, put this here, and then what you're going to want to do is use your calculator just to get this, and I'm going to do this all in one step, and you can definitely do this on a scientific calculator. I'm going to plug in 5 here, and it's going to be 0.0005 times 5 squared divided by 2 plus 0.003 times 5. All on one step. I don't need to see any work from here to there. You can leave it here and then do that on your calculator. Plug in 2, subtract the difference, and this is the increase. From year 2 to year 5, the temperature increased by that amount, according to this equation. On D, we have a particle moving by this amount. Here's the graph. The positive area here, and then negative. So this object is going positive forward and then backwards, and the positive area is bigger than the backwards area. For displacement, we're looking for this overall change. If you do this, it's going to put the positives with the negatives and give you 48. However, if you figure out where it crosses, set this equal to 0, you'll see it crosses at 6. We can just integrate between 0 and 6 and do that problem. That'd be 54 minus this. This positive distance up here is 54, and if we integrate from 6 to 8, we'll have this distance right here. This negative distance is 6. So what happened is the particle went right 54 and then back 6. 54 minus 6 is 48. But if we want distance, we want to add these together. So 54 plus absolute value is 6. Wait until the very end. There's lots of different ways to do this, but I recommend waiting till the very end of your work and then taking the absolute value. and then now you'll have 6. It traveled 60. It's 48 away from where it started, but it traveled 60. And probably the heart of the lesson is taking this integral from 2 to 6, finding the area with a trapezoid formula, finding the area with our limit definition, finding the area with our fundamental theorem of calculus. 3 different ways to accomplish the same goal of 36. All right, this is what you need to know for your test. If you have questions, please ask. Good luck studying.